We will further continue the solved MCQs related to the gases. If volume of a given mass of a gas is 2 liter at 10 degrees C, then at what temperature its volume is double at constant pressure? The options are given. So we will solve it according to Charles' law. V1 divided by T1 is equal to V2 divided by T2. Here volume V1 is given, that is 2 liter, and temperature T1 is also given, that is 10 degrees C. But in case of gas laws, we will convert it into Kelvin scale. So this 10 degrees C will be converted into Kelvin scale by summing it with 273. At what temperature its volume is double? So here 2 is given, so the double of 2 is 4, so we will put here 4, and temperature is unknown. So V1 divided by T1 is equal to V2 divided by T2. V1 is 2, T1 is 10 degrees C, but in Kelvin scale it is 283. 4 is not given in question, but here 2 is given, and in question it is given that the volume is double. So double of 2 is 4, and T2 it is unknown. So by cross multiplying and by solving it, we will get 566 Kelvin. Now the answer, all these answers are in degree centigrade. So we will convert this 566 Kelvin into centigrade by that is by this formula. 566 minus 273, we will get 293 centigrade. So the answer is 293 centigrade. Nitrogen pentoxide is completely decomposed on heating. If 2 moles of nitrogen pentoxide is decomposed, then volume of oxygen produced at RTP will be. There are many options given, so we will solve it. Remember, there is RTP, not STP. There is difference between RTP and STP. STP is standard temperature and pressure, and RTP is room temperature and pressure. So the volume of a given mole or given mass or given quantity of a gas is different at RTP than STP. So we will first write the reaction and balance it. So 2 moles of nitrogen pentoxide, it will produce 2 moles of nitrogen dioxide plus 5 moles of oxygen. So 1 mole of oxygen at RTP is 24 liter. Remember, there is given an option RTP. So at RTP, the volume occupied by the gas molecule is 24 liter. And the volume occupied by the gas molecule, 1 mole of a gas molecule at STP is 22.4 liter. So there is difference between these two. Then 5 moles, here the 5 moles are given in questions, in equation. So the 5 mole of oxygen at RTP will produce how much volume? So we will cross multiply it. So 5 multiplied by 24 liter. So option D is the correct answer. One liter of unknown gas weight 1.25 gram at STP. Possible formula of the gas is, so we will solve it. 1 liter, that is given in question, 1 liter is equal to 1.25 gram. So we know that 22.4 liter will occupy how much of weight, how much of grams. So 1.25 multiplied by 22.4, we will cross multiply it, so we will get 28 gram. So 1 mole of that gas will have mass 28 gram. So among all these options, which one of the following has 28 gram? That is carbon monoxide. Methane gas burned in air according to the following reaction. If 8 gram of methane is burned, what volume of carbon dioxide will be produced at STP? Here the reaction is given 1 mole of methane is burned in the presence of 2 moles of oxygen. It will produce 1 mole of carbon dioxide and 2 moles of water molecule. So here we will compare it methane with carbon dioxide. So we will solve it. Now methane is converted into carbon dioxide. So weight of methane is calculated as that is 12 for carbon and 4 for hydrogen. So we will get 16 gram, and here its molecular weight is 44 gram. Now when the molecular weight of a substance is expressed in gram, that is equal to mole. So both of these values are equal to mole. In question there is given 8 gram of methane. So we will convert it to 8. So for 8 gram it means that 16 is half, so it become 8. So 44 will also half, it will become 22 gram. So 1 mole is also half, it will become 0.5 mole. It means 8 gram is equal to 0.5 mole of methane, and it will produce 0.5 mole of carbon dioxide, because both these factors are half of the 1 mole. Now by using this equation, 1 mole of methane, it will have 22.4 liter of carbon dioxide, because 1 mole of methane when react with oxygen, it will produce 22.4 liter of carbon dioxide. This is volume of 1 mole. So 0.5 mole of methane will produce how much mole of carbon dioxide? So 1, it is half, 0.5 is half of 1, so 22.4, if we half it, then it becomes 11.2, or if we cross multiply it, then 0.5 multiplied by 22.4 liter of carbon dioxide will be produced, that is equal to 11.2 liter of carbon dioxide. Ammonium perchlorate decomposes according to the following reaction. Reaction is given. The total volume of all the gases produced at STP by the decomposition of 8 moles of ammonium perchlorate will be. There are options given in liter. First we will find the number of moles that is produced by the ammonium perchlorate. So 2 moles of chlorine, 8 moles, 2 moles and 3 moles of oxygen. If we sum up it, we will get 15 moles. This means that 4 moles of ammonium perchlorate when decomposes, it will produce 15 moles of gases. So 4 moles of ammonium perchlorate produces 15 moles of gases. Then 8 moles of ammonium perchlorate produces, if we cross multiply it, 15 multiplied by 8 divided by 4, we will get 30 moles of gases. Now the question is about the total volume of the gases. So we will get the moles of gases. So we can calculate the volume of gases from these number of moles. 1 mole of gas at STP will occupy 22.4 liter. Then 30 moles of gas at STP will occupy how much volume? 30 multiplied by 22.4 divided by 1, we will get 672 liter. So option B is the correct answer.